MPLS forwarding adjacency. In this video, I am going to talk about another method for forwarding the packets into the TE tunnel, the forwarding adjacency. It's so useful and also so interesting topics in the MPLS traffic engineering topics. Let me first review the methods that we learned until now for forwarding the packets into the TE tunnel. Let me write it here. Forwarding again, for example, traffic, okay, into TE tunnel. Okay, you know that we learned until now three methods for the forwarding traffic into the TE tunnel. The first method is the static routing. You learned about the static routing in previous videos. Also, the second method is the policy-based routing or PBR. You learned about this type of forwarding traffic into TE tunnel in previous videos, and also in the another video, in the previous video, you learned about the auto route announce feature, auto route announce. Okay, and now I'm going to talk about the next method. The next method is the forwarding adjacency. Forwarding adjacency. Also, we have another methods that I will talk about them in the future and also next videos. Okay, let me talk about this method, forwarding adjacency. What is the forwarding adjacency? How we can use the forwarding adjacency, how we can configure the forwarding adjacency, what is the detail of the forwarding adjacency. I will talk about all of this, for example, questions in this video. It's so interesting and also it is so useful. Let me first configuring, for example, small scenario here, R1 to R2 to R3 to R4 are connected. Okay, this is our networks, our simple networks. You know that in R1 we can configure a TE tunnel. For example, tunnel 0. You configured many of these tunnels in this course. Okay, these tunnel zeros started from the router 1 and for example ended in the router 4 as an example. Okay, you know that by default this tunnel doesn't appear, okay, in the routing table. You need to configure a static routing or PBR or auto route announce to for example use this tunnel 0 in the routing table. But in all of these methods only you have one-way tunnel, and this means that only the R1 can use this tunnel 0. Okay, you know that if we configure one GRE tunnel, let me use a scenario here. For example, when we are configuring GRE tunnel, you know that for configuring GRE tunnel, we need to configure on both sides a tunnel interface. For example, on R1 and also on R4. Okay, this tunnel can be used in R1 and also R4, and this tunnel exactly is like for example, a virtual link, a link between a direct link between the router 1 and router 4. Okay, but the traffic engineering tunnel does not work with, for example, such as the GRE tunnel. In traffic engineering tunnel, from the view of the OSPF or ISIS as the IGP, okay, cannot be seen. Here we have only one tunnel and we are using it. OSPF or, for example, ISIS, normally when you are using a static routing, policy-based routing, auto route announce, doesn't advertise this tunnel because this is not a real virtual link such as the, for example, GRE tunnel. The good news is that you can configure forwarding adjacency. After configure forwarding adjacency and learning about the detail of forwarding adjacency, you will have, such as the GRE, a direct virtual link between R1 and R4. It's so interesting and you can use it. But don't forget, for using the forwarding adjacency, okay, feature, you need to configure two tunnel in two direction. Okay, you know that the TE tunnel is a one-way tunnel. If you want to use the TE tunnel such as the GRE tunnel as a for example a link, a real virtual link between R1 and R4, you need to configure two tunnel with opposite direction. The first is from R1 to R4 and the second from R4 to R1. If you configure this two tunnel, and also you enable the forwarding adjacency feature, okay, you will have a virtual link between the router 1 and router 4. I say the virtual name, the name of this tunnel is not, the name of this link is not virtual link. This is not a physical link, okay? And OSPF can advertise this link, such as a connected networks, or ISIs can advertise this link. It's so interesting. This is the first time that we can use a TE tunnel, such as the other tunnels, GRE tunnel or some other type of tunnels in the routing table without using, for example, static routing, policy-based routing. Okay. What is the usage of the forwarding adjacency? The forwarding adjacency maybe can be used in different scenarios, but one of the most common usage of the forwarding adjacency is load balancing. Let me to talk about that. Look at here. As you can see in this scenario, we have the R1, R2, R3, R4, R5, R6, and R7. Don't notice to the tunnels. Only we have a normal IP routing networks, okay? Or for example, MPLS forwarding networks, MPLS label switching networks, okay? As you can see here, the path from the router 1 to router 7 is available from two ways. From R1, R2, R3, R7, and from R1, R4, R5, R6, R7. And you know that, as you can see, the higher pass, the top pass is the best pass because it has the lowest metric from the view of OSPF or ISIs. Okay. And also, we need to use the both pass or load balance traffic to in both pass. But you know that we can't load balance in this scenario the traffic between R1 and R7 from both pass. Why? Because, for example, OSPF or ISIs doesn't support unequal load balancing. You know it, okay? This means that we can configure, for example, only one, for example, such same metrics in the interfaces of the two paths, and we need to try to finding a solution to configuring same metric between the R1 and R7 from both paths. And this is not possible in all times. This is not a scalable method. How we can use both paths for sending traffic from R1 to R7? One of the best answers is using forwarding adjacency. Why? Because you can configure a tunnel between router 2 and router 3, okay, and also between router 4 and router 6. After configuring this tunnel, this TE tunnel with forwarding adjacency feature, we have these networks, R1 connected to R2, and then we have for example, tunnel 0. I'm going to configure this only for practice. You can use only in this pass the physical link, but let me to configure tunnel 0, and after that the R3 and then R7. This is the first pass. And then in the bottom pass, we have these routers, R1 connected to R4, then for example, tunnel 1, and after that tunnel 1 of the router 6, and then router 7. As you can see, the router 5 now does not available in the pass. Maybe you say that, what is the metric of the tunnel 1? Okay, the metric of the tunnel 1 is the metric of one link, because we have only one link between R4 and R6. Because of the now these two paths are equal, and now we can use the for example, equal load balancing features of the for example, ISIS or OSPF. Because of that, one of the most common usage of the forwarding adjacency feature is load balancing. Let me first reviewing the forwarding adjacency feature. After that, we can configure it. Forwarding adjacency is an MPLS feature whereby the IGP can see a TLSP as a link. Means, for example, this TLSP, and as I said before, the OSPF or ISIS can see a TLSP as a link, okay? The IGP on the head-end router of the T tunnel advertise the TLSP as a link with a certain IGP metric associated with it, okay? Any router in the same area as the head-end router then include this link when it's running the SPF algorithm, such as the normal physical links, okay? As such, the IGP sees the total path that the T tunnel spans as one link only. Look at here, one link only, okay? To correctly use